The next component in NASA's network of vital communication satellites will be placed into space this month to continue the task of relaying data and commands from Earth to the space agency's fleet of spacecraft. 30 years into its operations, the Tracking and Data Relay Satellite System has allowed NASA to expand its abilities to communicate directly with spacecraft like the International Space Station and observatories such as the Hubble Space Telescope, while being able to forego its network of ground-based communication stations around the world.
The TDRS Constellation brings back all of the data and video that we see every day from the International Space Station. In addition, TDRS supports all of the data from the Hubble Space Telescope and all of our low Earth orbit NASA science missions.
In other words, TDRS accomplished exactly what NASA designed it for. Its work is far from finished, however, and NASA's needs are not shrinking. That's why the agency is launching TDRS-L, the next member of the third generation of TDRS satellites.
TDRS-L will sustain the constellation and it will add to this national capability.
Like its predecessors, TDRS-L carries the iconic look of two large parabolic antennas and a set of solar panels. Those antennas, each 15 feet in diameter, provided a bit of a challenge since there is a limited amount of time they can stay folded and still unfurl to their proper shape. The processing teams kept close track of the time they were folded and had plans ready in case the antennas had to be opened if there was a lengthy launch delay. Identical to TDRS-K, which was launched in 2013, TDRS-L will take its station in geosynchronous orbit more than 22,300 miles above Earth. From there, it can basically hover over a point on Earth and communicate with every satellite and spacecraft below it, along with NASA's ground stations and other TDRS satellites. Working in conjunction with the 7 other operational TDRS platforms already in space, TDRS-L lets NASA stay in touch with its Earth-circling spacecraft at all times. In fact, TDRS spacecraft already in operation will help track this newest member of the family as it climbs from Cape Canaveral Air Force Station in Florida to its new home in space aboard an Atlas V rocket.
If you only had antennas in Africa, the middle of the Indian Ocean, and Australia, you generally are faced with certain coverage gaps. But looking down from the geostationary orbit of the TDRS constellation, you're able to seamlessly cover the entire period of a launch vehicle trajectory.
The United Launch Alliance Atlas V rocket that will power the 7,600-pound TDRS-L off the launch pad to its orbit location arrived at Cape Canaveral in October to begin a couple of months of processing.
Luckily, TDRS-L has been a very smooth flow. TDRS-K, which also was a smooth flow, but it was kind of the first time we had launched in about 10 years, a TDRS satellite. And it was now launching on a new vehicle. It launched on a former Atlas, now it's launching on an Atlas V. So we were able to apply a lot of the lessons learned that we went through the TDRS-K flow into TDRS-L.
The Atlas V, which includes the venerable Centaur upper stage, is relatively new to NASA's launch catalog, but has taken on the mantle of NASA's workhorse booster. In recent years, it sent probes to Jupiter, Mars, and the Moon.
Although it's reliable and has been very successful, we don't change the way we go into a launch campaign or into a mission. We have very strict requirements. So although we know it's very reliable and very successful, we don't diminish our involvement in any way, shape, or form. We're always give it the same level of rigor that we would do for any mission, whether it was the first or the 50th.
While the Atlas V is a newer booster, the Centaur is celebrating its 50th year in service. Developed at NASA's Glenn Research Center in Ohio, the Centaur was the first to use liquid hydrogen for fuel in a mix with liquid oxygen. Its success paved the way for later hydrogen-fueled engines, including those on the second and third stages of the Saturn V rocket and the Space Shuttle main engines. Launch day is January 23rd for the TDRS-L. For the launch team and those who build and process the spacecraft, it will be a testing time, which is normal for every launch day, no matter the mission.
So the last, 4 minutes when you're going to terminal count, it's just one after another. You don't have a whole lot of time. You don't have time to stop and start doing things, and troubleshooting. It's very intense.
I've been tremendously lucky to have a highly capable team. The United Launch Alliance and the Launch Services Program team is just exemplary. I couldn't ask for anything better. And in that regard, I like to make sure that the team as a whole is focused on launch day, that we're ready for the countdown, that we've done all the steps necessary leading up to launch day that will ensure a flawless execution and mission success.